Well, greetings and salutations, everybody. So here's what we're doing today. I'm just gonna make this short video because I never really realized that I haven't made a supplemental video on how to. I've used a technique over and over again to actually model out flat versus curved and compare the difference. I've used it in tons of videos, and but I never actually did a single video to actually show how this is done and how you yourself can do it 100% for free. Now, what we're going to be doing here is the software that I'm using is called Gmax. This is a light version of more popular 3ds Max and 3ds Viz of old. This software was actually originally released for making models in for 3D games, using the very powerful Discrete engine, which was the original company before it became absorbed into Autodesk, which makes AutoCAD and all that. Now, since Discrete itself no longer exists, there's a website out there called Turbosquid, which is a great site for making and trading and selling 3D models that you make. They assumed the licensing rights for 3ds for Gmax. And just to show you real quick here, if you go on to Google and you see I just did that here. Now, there's a Gmax GVK. That is not what you're looking for. You are looking for, when you Google Gmax, you're looking for the one that's under Turbosquid. Turbosquid, again, is a great website for 3D models and selling. But what you want to do is you'll obviously want to download this, and then what you will have to do is you'll have to register on the Turbosquid. It doesn't cost anything. They don't spam you. It's totally square. But when you go on to this site, you can get the license key for Gmax. That's how you get that. It's simple. You download it, you install it, um, and you're good to go on that. Now, I changed the colors on this to match the 3ds Max that I'm more accustomed to using. This actually comes in as a gray background with black lines, and I find that to be, me personally, just it's not comfortable for me to view that. So and the way you change that is to go into under customize, customize user interface, and you change the colors. Set it up how you want it. This is just how I like it, and so you'll notice this difference when you actually download it and install it. But let's go ahead and dive right in. This is the viewport, obviously. You can view multiple things at the same time just by simply right-clicking on whatever the title of each window is, and you can change the view type from solid objects to things with lines on them, etc. And then, of course, the views themselves. You can have these are solid preset views, or you can use the tools down here to change your views however you want to look at them. We're primarily going to concentrate on orthographic view here, so I'm going to show you the camera views at the end, but ultimately the orthographic view is what we're dealing with here. Now, down in the lower right corner here, you can change the view settings. It's the minimize and maximize toggle. Now, if you right-click that, you can set up the viewports however you want them. If you want to look at multiple things at the same time, or if you want to find adjust something, etc. There's so much flexibility on what you can play with here, and even when you're in there, you can actually drag the lines if you want, a smaller view here, or whatever the case may be. But I'm just going to click on it one time. That's left click. That just basically zooms in on whichever viewport that you have selected. So if I were in perspective view, which is basically showing depth without being bound to a camera, you can go like this. Or if I wanted to be in front view, I can go like that, or I can actually just right click the title and move to whichever one I want. Pretty simple stuff. again, like I said, I'm not going to go too much into it, but I'm just going to give you the stuff that you need to know about to do this however you want to, and you can build your own stuff. So we're going to go into top for right now. Front will be our primary viewing area. Now you can zoom in and out using the wheel on your mouse. It's pretty easy stuff. You can zoom into specific depths. Just do whatever you need to do. But in a minute here, we're going to be using units, and those units are going to be in kilometers, and we'll show that in a second. So what I'm going to model out, I was trying to decide which one I wanted to actually demonstrate on here, and what I'm going to model out is everybody is already aware of the second most popular video on my channel, which is the you wanted curvature, which was the Frankfurt observation. I did this 3 years ago. I used a different technique in modeling it out. I just basically did drops as opposed to actually curving it. So I just wanted to do this technique just so you can show what it comes out to. And here's the data that's in that video. I show it right up front. That's the data that's actually being used, and this is the data that I have actually transcribed over to this. Y'all can check the numbers, pause it, whatever you need to do. These are the numbers that are going to be associated with this model. Pretty simple stuff. I got some distances, I got the ground height, I got the object heights. For example, the tower that I was standing on when I took the photo, it's 27 meters higher than the ground level. The mine tower is the name of this building. The distance to it, the ground elevation below it, the building itself, and then of course there's this mast up on top, which is an additional 40 meters high. And this is all researchable information. I also have it listed in the video itself. And then what we're going to worry about, we're just going to worry about one of the mountains here, and that's the Franz Kopf, which is back here in the back. I have the distance to it, and obviously its elevation above mean sea level. So that's the data that we're going to be using here. And so let's go ahead and get started. So the first thing that I need to do is I need to build a test track. Now, doing this over and over again, I have found some simple ways to do this, and so I'm going to show you the method that I use. First thing I'm going to do is I'm going to create a plane. Over here on the tool side here, you want to make sure that you're selected on geometry, and you want to make sure that you're selected on the main window, which is this one with the arrow on it. Select geometry and then select plane, because all I'm going to be making is a plane here. And now what you draw here, I'm just left clicking and dragging to whatever size I want. Because I'm going to refine those sizes actually to detail in the rollout on the right side. So I right-clicked it, or excuse me, I left-clicked it, drug it out, and now I have this object. This is going to be one of my surfaces. So, and then what you want to do is while you're selected on it, you can check. You can also select if you want to move it, if you want to rotate it, if you want to scale it. But we're not going to worry about any of those. All we're going to be doing is moving. So now up here on the top right here, you want to select the Modify tab. That's going to go into the guts of whatever it is that you are what you are using. And now I'm going to select this and just kind of move it over here, but it's not important at the moment, because we're going to be lining all this stuff up here in a second. Now obviously you can see the width here, the width value here, and then the length value here. You can change these. That's how you refine this. Now my whole numbers are going to be kilometers. That means the numbers that are in front of the decimal point are going to be kilometers, and obviously the numbers behind the decimal point are going to be individual meters. That's the beauty of using the metric system. So because we know that if you use, and I know I'm going to hear the word presupposition here, but in order to check numbers, you actually have to verify the numbers. So I'm going to use the numbers that exist. If you took the circumference of the Earth in kilometers, which is 40,075 kilometers, and you divide it by 360, that comes out to 111 and change uh, kilometers per degree. That's what's important here. So I'm going to put this at 111. That's going to put that down to 111 units. The units, like I said, in this case are going to be uh, kilometers. So from there, I'm also going to reduce the length just for size purposes. There's, like I said, I'm just making it ground here. So I'm going to reduce the length down to 1. Okay, so now what I have here is I have a stretch that is representing 111 kilometers wide here by 1 kilometer width, which is basically going to be the reverse when we're working with it. Now, what you can also do is you can also work with the length segments. Now, obviously, length, we're not worried about anything there, but since we're going to be bending this at one point, we want to make sure that it has enough bend points to make a nice smooth curve. Now, the easiest way to do this is just the more bend points you have, the smoother the curve is, but we're gonna do this in increments, so I'm gonna do this just at 111. I think you can only go up to 200 per object, so sometimes you might have to play with that a little bit. So I have a 111 kilometer stretch here, broken up into 1 kilometer increments. Nothing more amazing than that. Now, all I'm going to do is manipulate that around here, and I'm going to go down here. Now, one thing that you need to know is if you want to zoom in on something, you could have the actual pivot gadget. It might be out of your view. So what you want to make sure that you do is, if you know you're going to be moving it left and right, then move it one time left and right just by clicking on the axis direction, and it will remember that, so that when I go in here to zoom in on it and then I select it again, it's only going to move left and right. If I try and go up and down, it's not going anywhere. So what I just want to do is I'm going to use this as my anchor point here in the middle. So I have a 111 kilometer stretch along this area. Pretty simple. So now this is an experience point because of the way the pivot likes to locate itself when you go to bend something. What I do here is I hit shift and then I just click and drag, and basically what that does is that creates a second one of these, and I'm doing that because of the fact that I want the bend point to be in the middle, as opposed to trying to make it bend from the start by screwing with the pivot. So what I'm doing is I'm making a backside to this. This is not going to be something that you are going to use in any of your observations, of course, but this is just an assistance in the model, and you'll see what that is here in a moment. So again, zoom in. Sorry. Zoom in and click on it, and I'm just going to drag these so that they both meet as close as I can get to it. Alright, so got both of those. It hung on to it, sorry about that. And then I'm going to take them both and make sure they're right here on this anchor point. Pretty simple stuff. Now, because I know I'm not going to use this portion, I'm going to select on it, and then up here you can change the actual vertex colors. You've got a whole bunch of colors that you can choose from, and anything that I'm not using, I'm just going to color red. So now I got a red side and I got a green side. Now, this is going to be the flat model, so I am going to make the green side, or the flat side on that model. I'm going to make that we'll just, I don't know, you can pick whatever color you want, but I'm going to use pink. Okay, simple. So right now I have my track. This is a 222 kilometer track simulated, and of course when I go into views on front, it just appears as a plane. That's all it is. It's just a line. So that part is done. Now you have your track. This is going to be the starting point right here in the middle, and everything that we're going to be extending out is going to extend out to the right here, because that's going to be my viewing location, or that's going to be my observation location. This is where the observed objects are going to be. So in this particular case, we have the first thing that we have to model out is the observation location. So according to this, I have the ground is 295 meters up, and the tower is an additional 27.5 meters. So to keep ourselves in line, what I'm going to do is I'm going to create a box. The reason why is because I mean, I could do this with normal, just with a normal rectangle line, but it's not going to help me when I go to do the camera view. So you actually want a three-dimensional object for that. So I'm going to do a box. Again, just going to drag a box here. Now, when you let go of it the first time, that is those dimensions, the length and width. But now it is also, if you can see over on the right, the height is changing. That's going to be the depth. So you want to move it to whatever depth, it doesn't matter, because you can do all these adjustments later, and then hit the click one more time. And then now it'll create the object. The reason why I'm telling you that, let me go ahead and show you this, because if you just let it go like that and then right click off somewhere, it's going to disappear. It's not going to create it because you didn't set a depth. So what I'm going to do is click on it like this, then move, and then one time left click, that sets the depth, and then right click to get off of it. Pretty simple stuff. So let's go ahead and get the measurements on this. Measurements on this, what was it again? It is 295 meters up. So we want, and you can sit here and you can drag these and move them all you want. So because kilometers are the whole numbers, we are going to be 0.295 kilometers, which is 295 meters. Okay, and because we don't want it to be ginormous like that, we'll just put this at 0.050, 50 meters wide. Now, we zoom in on this and we can drag it into place. Oops. Come on. There we go. Now where I'm going to end up putting this is I'm going to put this right down here at the beginning. The reason why I'm going to do this, now like I said, these are just markers. Now if you wanted to go into much further detail, you can model this thing to your heart's content to make make it look structurally correct, but right now we're just worried about heights and distances. That's all we're really worried about. So right now I have my 295 meter high ground. That's this level right here is 295 meters. Now I have to put an additional height of 27.5 meters, and we want to make sure that we recognize which part is different. So if back in here, when I'm selected on an object, if I hit the shift button and then I move in any direction, it creates a copy of that object, or you can cancel it and it goes away. But it creates a copy. So first thing what we're going to do is I'm going to create a copy here. Now you can rename it here, or you can rename it over here in the rollout. So what I'm going to do is first, this is going to be called, the bottom part, the 295 meters, we're going to call this tower ground, because that's just the ground below it. Then this one we're going to call tower OP, which is the tower observation point. That's all it's going to be. Now all we're going to do here is we're going to change the length, which is this way, and that length is now going to be 0.0275. That is 27.5 meters tall. Simple. And then what I'm going to do is I'm going to select in on it and raise it up so that as clean as you can get it, it meets right up to the edge. So now what I have represented here is I have the height of the tower above the height of the ground above MSL. That's going to be, this point right here is going to be the height of my observation point. Pretty simple, right? Oops. Looks like my stuff all moved here. So what I'm going to do is, and this happens sometimes when you're just moving fast, or when you're zoomed way out, you might not be getting as accurate as you thought you were. So what I'm going to do here is I'm going to group these, and I'm just going to call this the tower group. That way, when I go to move it, it all moves together. So make sure that I'm selected on the up and down axis. So when I go into here, I put it right up on the ground level perfectly. Pretty simple. So next thing we're going to do, now we have to put objects out at a distance. There's a tool here. If we go back into the object creator here, there are a couple of different types of objects. You can put in lights, you can put in cameras, there's different systems like particles and all that neato junk. But all of that is kind of uninteresting to us at the moment. What we want right now is a helper. And that's what the little tape measure here is, because that's exactly what we're looking for, is a tape measure. So what this does is, first you want to get as close as you can to where you want to measure from, and you just click and hold down and then drag in a direction. What that's going to do is that is going to drag out a target for your measurements. Now, all the way down here, first thing I'm going to do is I want to make sure that I just start off right. Is this here is the starting point of whatever measure that you're doing. And this here is the target. Now I'm going to drag this target all the way out to the end of my test track. The only reason I'm doing this is to make sure that any measurement that I do is going to be even with the surface below it. But go back here and select on the triangle that starts the tape, and then go over here to modify, and just like before, you can see the guts of what it is. Now, this is only going to be readout guts. The only things that you can change here at the tape is the actual length of the tape. It will tell you all the information above which axis, what degrees, etc., etc., etc. But we're not worried about that at the moment. You can go into that as deep as you want to at a later time. What we want to do, though, is we want to hit specify length. And that'll reduce it all the way down to 100 off the bat. And what that did was that changed this green line. As you can see now, this green line no longer goes all the way out to the target. It's still pointed directly at the center of the target, but the line itself is now to a specific length. And we can use that because next guy that we're going to is 16.9 kilometers away, because we're moving on to modeling out the tower now. So what we want to do is, in here, we're at specify length, and I'm going to go to 16.9 kilometers. Now what that's going to do is, as you can see, it got considerably shorter now, because now this is a unit distance of 16.9. This is where we're going to be modeling the tower, or the mine tower. And once again, we're going to do things exactly the same way as we did them before. What we're going to do is I'm going to model a box. Again, dragging and dropping, and then clicking a depth, and then right clicking off of it, and then just putting it right here to the edge, because we are going to refine the measurements as we need them. So, wait, is that, hold on. Alright, so just want to make sure, well, actually I don't know why I did that, because that's going to move here in a minute. Okay, so first we're going to do the ground. The ground is 101 meters above MSL. So we're going to go like this, length 0.101. That is the ground height. So let me go ahead and get this squared up here. And one thing you will not notice is me pushing any kind of a button that says fake the globe. Alright, so width, I got that at, well, we'll just put it at 50 meters. All right. So, and I want to make sure, oh, a little glyph there. So, and I want to put this right up here at this edge. Now you can make this as thin as you want because like I said, we're only using reference marks here, but the distance goes right up to the edge here. Now, again, I'm going to hit shift and move up because we're going to go to a second object. The second object is going to be the building itself. The building itself is 200 meters tall. So we will go ahead and change this one. 0.200, which will come out to 0.2. That is going to be the tower height itself. Okay, put it as I did before, just make sure that you measure it right up to the edge. That's the tower height itself. And then I'm going to change the colors here in a minute. I realize it's probably, actually, let me go ahead and do that. Change to something a little bit brighter, something that could probably be seen a little bit better in the live stream. And then now we have one additional thing to do here, and that is going to be the mast on top of the building, which is 40 meters tall. So again, 0.040 like that. And that is the height of the 40-meter mast that is at the top of, at the top of that building. So right there we have our ground level, then we have the building, and then we have the mast on top. And again, we are going to make that into a group, and we're going to call that the main tower group. That way, if I go to move it, if I wanted to get a little bit more refined on it, or if I wanted to move it around, I only have to select on it one place and it remains as a group. So, and we got one last object we got to do, and that's Franzosenkopf, and that is 56.6 kilometers away. So we just go back to that very same tape. Don't modify, don't change the target or anything. All we want to do is select on the triangle, and we want to make sure that this says 56.6. So that's 56.6 kilometers away. And guess what? Line got longer, and this represents a distance, a surface distance of 56.6 kilometers. So, and one more time, this time we just got to do one box because this is a terrain feature, and that's the only part of it that we are measuring. So again, I'll go back here, my width, I'm going to put 0.05 just to keep everything together. I will give it a obscure color. We'll just go orange while keeping it bright enough that you can see it. So, and before I zero it in on the ground, let's make sure the measurements are correct. The measurements that I have is 484 meters. So we'll go for 484 meters. 0.484. Now we can refine it down to the ground. Or in this case, MSL. Get that there. So now we have our complete model, our test track. Too distant, and I can go ahead and delete this because I no longer need that tape measure. This is the ground below the observation point. This is the top of the observation point. This is the mine tower, which is this is the ground below the mine tower. This is the mine tower building itself, and this is the mast above it. And then, of course, this is the mountain way off in the background, and its elevation and scale distance. The reason why I like to do modeling this way as opposed to the earth curve calculators, which I have absolutely no problem with, but the problem is that earth curve calculators, they use a chord distance as opposed to a surface distance. And so that is the one thing that flat earthers love to completely get wrong when they say that even like Mick West explained on his page that the distance that's involved decreases in accuracy over greater distances. And the reason why is because it's measuring a chord instead of surface distance, and which is perfectly fine for geometry and rational people, but flat earthers seem to think that that means it's broken. Anyway, so what I'm going to do is I'm going to grab all of these objects. Okay, I have the backtrack, and oh, by the way, I'm going to go ahead and just rotate this in orthographic view, just so you can see that. Oh wow, I got that all. I'm sorry, I moved that. I made the. Well, let me go ahead and change just the width on that. Sorry. No, that's not what I wanted to do. Where's this? Okay, well then screw it. I won't do it. Something about having the streaming software on is screwing with this. So, screwing with my ability to manipulate it. So I'm just all I'm going to do is I'm moving this back. This is the tower and the observation point. It's just that I never adjusted the depth. So sue me on that one. Doesn't matter. It's not going to matter anyway. So I have all this. This is the back 111. This is the front 111. This is the group for the tower, or excuse me, the observation tower. This is the one for the building, and this is the one for Franz Rosenkopf, the mountain in the distance. So what I'm going to do is I'm going to select all these, and I'm going to make them into a group. It doesn't matter what we call the group right now. It really doesn't matter. And then, just like I did with the individual objects, I'm going to shift and drag it, and now I've made a identical copy along the exact same view. So if I go like this, if I go back down to front view, it's going to look absolutely identical as if there's only one, because they are in direct line with each other. It's pretty simple stuff. However, what I'm going to do is I'm going to rotate the view so I know which one I'm looking at. I'm going to select on one and then hit group and then open. What that does is that retains the fact that it's a group, but it allows you to tap on the individual objects inside of it. Why does it look like? Oh, that's because of the group line. All right. So what I'm going to do here is, first thing I'm going to do is I'm going to change the color of the front side so we all see what's going on. And because the Earth is mostly covered with water, we're going to go ahead and change that to blue. So that just distinguishes the two from each other. If I select on any of the objects inside of here, again, just as long as I'm selected on one of them, and I go back to group and close, basically that just closes the group back up, and it is a single unit again. I just manipulated the color on the front side here. Now, this is where the comparison comes in. I'm going to select on the group that I'm considering as the curve group, and then I'm going to go over here to modify. Same place that we were getting the guts of information, but you're not going to get a whole lot of modify things on here, so you have to hit the drop down, and these are all the different modifications that you can do to things for whatever reason that you would have to do them. If you were going to mask them, if you were going to skin them, if you're going to put materials on them, etc. But the only one that we are worried about right now is, why can't I see it? Hold on. Let me select this again, like that. We are looking for bend. Oh, okay. I'm so used to 3ds Max where it's actually in a category higher. Sorry about that. So we are going to use bend, because what we're going to do, oops, I skipped a step. My bad. Hold on a second. Let me trash that. Not going to bend it. Not yet. Because what I need to do first is I need to go back into views, front, because the when I'm selected on it, the pivot object right here is kind of at an average between all of the objects selected. However, I want to make sure that it bends right in the middle, because if I were to choose bend right now, it would bend from this point, and my although the results would be the same, it doesn't make it as easy to tell the difference. So what I'm going to do is I'm just going to hit hierarchy here, which is up here on the top, and then hit affect pivot only. What that's going to do is that's going to give an alternate location for the pivot of where I'm going to do the bend. Now it will still be an average height, but it will be in the middle of the object left and right. And what I'm going to do is I'm just going to drag this down because I want to make sure that when I bend the surface, I'm bending that all the degrees that are shown are based on the MSL line. So done with that, I can move away from that. I can move it around as much as I want now. And then I go back over here to modify, and that pivot stays in the same place. And then I'm going to go down here to bend. Now what this is going to do is you have 3 different axes and 3 different directions and all this other stuff. All we're worried about in this particular case, I won't go into the depth of all the other stuff, is we want to bend on the x-axis. And you can see that when I rotate it up and down by however many degrees, let me zoom out, you can see it even better. This is how many degrees of angle that I'm rotating this. Okay. Now, we have 2 stretches of 111 kilometers. So what I'm going to bend it by, which is 2 times 1 degree, which is obviously 2 degrees. That is the amount of Earth curve per the stated circumference. This is called verification. You can call it, presupposition, but that's what a hypothesis is anyway. And what that did was that bent the entire blue stretch by 2 degrees. 1 degree to the front, 1 degree to the back. And you can see the difference on this. So, now I have 2 tracks. Let me go ahead and rotate this view again. Now I have 2 tracks. 1 track is bent, 1 track is not. Oops, let me go ahead and try and get in a little better here. 1 track is bent, 1 track is not. Everything in that group bent with it. Pretty simple stuff. This is where we get our, now we can do our comparisons. So let me right click on this and go back to front. Now what I am going to do though, just for, you're going to see that I'm about to move the entire curve track. And all I'm doing is I'm going to make an offset, because basically let me show you why I'm going to do this. First of all, obviously the observation point, they both look identical. This is one in front of the other of 2 of the exact same model. So here is pretty much the same no matter what we do. However, as we go down in distance, you're going to see that one is lower than the other, and we want to make sure that we're looking at the right ones, because one is sinking due to the curvature of the Earth, or the curvature of the track in this case. These 2 are both sinking. So I want to make sure that you can actually see the difference and know which one you're going at. Now you can also go back in and change colors on stuff and all that, which I have done in a current video that I'm working on, but I also offset it because I want to make sure that I can see exactly which one I'm dealing with. So everything in this entire thing just moved. Okay, these moved to the right. These moved to the right. Now that just means that all I did was I slid one entire track to the right, so I can distinguish the difference between things that are of similar color or similar design. Now, if we just want to do the geometry portion, there's a very easy way to do that, and that is under the create, instead of objects, you want to hit shapes. And here's a couple of preset shapes that you can do, and you can also do all these in shapes if you wanted to. But in this case, all we're worried about is line, because we are going to judge out the line of sight and what meets what. Now, what you're going to want to do not drag, but tap. Okay, so I'm going to tap right here because this is the observation point for the flat track, is the one on the left. So I'm going to tap once, and that's going to start a line. Do not drag it. If you drag it, then it's going to want to drag a curve, and which can get a little bit interesting. But and then what I'm going to do is I'm going to take this all the way out to the peak of Franz Rosenkopf on the flat track. Oops. Sometimes you got to zoom out on it, otherwise it thinks you're too close. See, it made a pivot point now, but all I have to do is right click at that point, and now I'm no longer making any lines. So this line right here is the line that we are worried about. If you would like to modify and detail its position, you go back to modify, and then you got three options here: by spline, by segment, or by vertex. Now we want to do it at vertex level because all we're going to do is change its location, its target location. So I'm going to put it right here at the edge. Simple. And it's still in modified mode, so I can go over here and refine this if I need to. Yeah, I can refine that a little bit. You select on the vertex and you put it right where it needs to go. Pretty simple stuff. Now, one other thing that you want to do on here, if you are planning on putting your lines in, if you have multiple lines that you want to measure, one other thing that you want to do is you want to make sure that under interpolation, when you are selected on the line, under interpolation, you reduce the amount of steps to 0. That is how many segments, how many breaks there are in the line. So if you were to go to bend this, or bend an entire group, that line will remain straight. The line itself won't bend. It's just its reference points at the beginning and end will bend with it, but the line itself won't bend. It's just the two target points. So we got that. Now, right now we already have a model to find out what is the difference between the observation that is made. Let me bring the video back up. Now, as you can see in this particular video, from where I was standing and the photo that I took, Franz Rosenkopf is inside of the height of the mast of the Main Tower. So let's find out if that matches plane or curved geometry. So let me go ahead and brighten this up. I'm going to make this yellow just so we can all see it real well. And we know that right now it is set to the observation point. Honestly, these two observation points are negligible, meaning that if I moved the dot to here or to here, it wouldn't matter. It's going to be the same because they're just so close to each other. But nevertheless, now what I'm going to do is I am going to hit the pan and just leave it in its same distance. And we're going to move this. Well, let me zoom out a little bit. Okay, there we go. Get over there a little faster. Now what you can see here is the line of sight going to the top of Franz Rosenkopf. This being the this one on the left being the Main Tower and the Main Tower mast across the plane geometry, which is this one. You can see that the top of the mountain is almost a whole nother mast high above the original mast, which you do not see here. That would mean that Franz Rosenkopf would actually be up about here, almost here at the words, probably between the words and the numbers here, about this height. However, that's not what we observe, so we have to wonder if there's a question there. And as I said, this is going to the peak of that particular mountain. Now let's go ahead and move this line, because now that we know that it doesn't work across the plane, let's go ahead and move the line, and we're going to check against the peak across the curved surface. And let's go ahead and make sure that we get out here, because I know somebody would have something to say about it. So let's just go ahead and move the beginning point of the line out to the observation point on the curved model. Oops, let me go ahead and get out of this. So all I did was change the two peaks. And we will go ahead and move this over. And like I said, this is something, I've done that. I do this much faster when I'm doing it by myself, but I'm explaining everything because I want to make sure that everybody knows exactly what it is they have to do if they're not familiar with the environment. Now look, the line of sight, because on the right side one now is the one that we are dealing with, which is the curved earth one, goes right through it. The line of sight to the peak of Franz Olsenkopf goes right through the mast of the building. And look, right about here, just a little bit off. And the only reason why we can consider that a little bit off is because it's probably got about 20 to 30 meter trees on top of it. But either way, it's inside of the mast. So you tell me which one reflects reality better. Pretty simple. Okay? Now, let's go into one last little bit here. This is just a supplemental point at this point. So let me go ahead and I'm going to remove that line just so it's not something that's graphically in the way. Now, if you want to do comparisons, if you want to view things, because everybody likes to say, oh, that's not in perspective. So let's go ahead and hit cameras. And what we want to launch is a target camera. Now, just like the tape measure, a target camera is basically a camera that you start and drag, and then that pulls the view of the camera to a target. And this right here is the field of view that it's the default field of view. So what I'm going to do is I'm going to drag this target all the way out to Franz Olsenkopf. Now, sometimes you can move it up, sometimes you can move it down. I mean, you can do whatever you want at that point. I'm just going to leave it in the middle of the two. It doesn't matter. You can change it however you want to. And then what I'm going to do is I'm going to view from the left side. And what that's going to give me, these are the two models. Okay, this is the curve, or this is the flat model, this is the curve model. Now, since this one right here, this is the camera that I just made, because it will always start at the 0 line. Now, I have one camera there, and what I'm going to do, same as I always did, is you got to make sure that you select the target too when you do that, otherwise it's going to move it, but it doesn't matter. You can move it back. But I'm going to drag a copy of that camera over to the observation point on the curved model. Okay. Now, to keep yourself aware, what I did was now I'm going to select the one that's above the flat model, and I'm just going to call that the flat cam. And then this one, I'm going to call this one the curve cam. This is just so you can see what you're using. If you had to, up here there's a list view if you wanted to select things by their actual names inside of the viewport. So what I'm going to do is I'm going to, and which we're going to use here in a second. So I'm going to select the flat cam first. Basically, this is a camera with perspective, even though it's not perspective, because perspective is an artistic technique, but with depth is what we're using here. And I'm going to go up here onto this list, and I'm going to select flat cam, because that's the one I'm looking through. Hit select. Then over here on the rollout, under modify, where we can see the guts of it, there's all kinds of things that you can mess with. But all we're going to do is reduce the field of view. In other words, we are going to magnify. So I'm going to reduce the field of view. Which magnifies the image. Now, as you can see, because a lot of people like to argue pretty nonsensically to say that, oh, things get smaller due to distance. Yeah, but they never go below the level of the observer across a plane. So, especially if it's higher. So here's what we're looking at. And so Franz Olsenkopf is obviously, as we stated a second ago, almost a full length of the tower mast higher. Pretty simple stuff. And for those who wish to argue camera angle, let me go back into this. Now, right now we're at flat cam, and what I'm going to do is in front view, I'm going to select flat cam target, which is just going to point out the target. Now if I turn this up, if I turn this down, okay, that relationship does not change just by pivoting up or down. And if I rotate, it also doesn't change it. Same with reality. So we got that. Before somebody wants to argue, I'm going to put it right back to where it was. So let's go ahead and go to curve cam. Actually, I can do both of them. It doesn't matter. So views, we'll go to flat cam here. Oops. Now it's in smooth and highlights mode. We want to keep it in wireframe mode just so we can see all the details. And this one, that's the curve cam. So let me go over here and select, this is the curve track cam. And let me go ahead and zoom that one in. Let's see, so what do I have in that? I got 4 on that one. Let me make sure I'm on the same level on both of them. I got it on 5 on that one. So these are both at the same zoom level. And let's see, who's do I got? Okay, that's the flat one. So no change. Oops. No change in relationship. But what you are seeing is that the top of Franzosenkopf is in the middle of the mast area, which is also seen in the observation. So if you want to have a discussion of what matches what, it's pretty simple. Anyway, I am not going to go much further into this. You can use this at your own will. Again, it's called Gmax, and it is found on the Turbosquid website. It is 100% free. Yes, you do have to register at Gmax, and if you're into modeling, you might actually dig being there. But you do have to register at Gmax, but they don't hit you with anything. So, I mean, I've been a member of Gmax or Turbosquid for a long time. You don't hear from them unless you sold something or you go in for their newsletters and stuff. So that's where you get the tool. And if anybody has any questions about how to use this or recommendations about better ways to do things, make sure you put it in the comments below this video, and I will be happy to answer anything. And would love to hear anything that somebody, you know, if you've done a model about a video and stuff, you know, go ahead and link it in the video or in the comments, and I'll gladly make sure that that comes through spam. So that people can see that you've actually used this to debunk and also measure other claims. Pretty simple stuff. Ladies and gents, that's all I really got for today. Sorry I made it as long as I did, but again, I wanted to make 100% sure that I got this video out because I have another video that I'm working on right now. You'll recognize it as the egg video. And this is just showing how I model this stuff out, because you're going to see one of these models in a little bit more detail in action in that particular video. I thank all y'all for stopping by. And again, if you have any questions on how to use Gmax or how to model some of this stuff out, or if you've done your own models, just go ahead and put it in the comments below the video. Thank you for stopping by. And I'm not even going to do a boom on this one because, well, I'm tired. I just got off night shift. Y'all have a great day.